Hello, welcome to today's video on our physics lab that we just did. So the lab that we just did was the free fall lab, and so what we were supposed to do was to find the acceleration of the object due to the gravity of it. Now we were given a stopwatch and a small little eraser ball, and right here's our diagram. You get to see here, kind of, we're dropping it from the second floor at our school, which is at Tampa Prep, and we're dropping it about 5 meters. We're dropping the ball about 5 meters, not the phone. And then we're using our phones or our iPads as stopwatches. So what we decided to do from there was that we took about 5 to 6 trials. For us, we decided to do 6 since it gave us kind of a better number in terms of average. So anyway, we dropped the ball about 6 times from the second floor railing, and pretty much we tracked how long it would take for the ball to hit the ground. Now we're also trying to see the impact of gravity on the ball's acceleration. So we were given the distance, and then we were to use the time, the average time that we found from our 6 trials, and then we were to find our acceleration from there based on this equation right here. Now we're using this. Normally our original equation would include initial velocity and other few of those variables, and we aren't using initial velocity because the initial velocity is coming from rest, so that would be 0. So therefore we would only need this part of the equation, which is half times g times delta t squared, which g represents acceleration. So what we did here, I'll actually move to my notebook. We were given this equation, right? And so pretty much what we did first is that I found my knowns and unknowns. So my unknown here is my acceleration, my known is my distance or my displacement, and then my average time is 93 hundredths of a second. So then we would solve for our unknown, pretty much just move everything to the other side kind of deal right here. And then we would get 2 times the displacement over time squared equals the acceleration. So we would substitute those values then, and then we would solve, and then we got, for our experiment, we got 11.56 meters per second would be our acceleration. Oh, second squared, my bad. And then what we were to do here is that we were to find the percentage error. So hold on, let me get a pen real quick. So our accepted value was the value that we were given, or the value that that is thought to be theoretically correct, and that would be 9.8 meters per second. And then we would minus that. We would minus our experimental from 9.8. We would put it over the accepted, and then we would times that result times this number by 100. And so what that ended up to be was 18%. So that means we were about 18% off from what our experimental value was from the accepted theoretical value of 9.8 meters per second. So there you have it. That was our lab, and those are our results. What could have possibly gone wrong was some of the time trials that we had going on in our experiment, such as like maybe some minor flaws with each individual time, in that we clocked the ball at different intervals of which it was being dropped, so it wasn't, as precise as we wanted it to be. But fortunately for us, we did get a pretty reasonable average time, so I think that made up for some of the error that we kind of got, the 18% error that we achieved during this experiment.